Okay, so today we are going to do redox, and in redox, you guys must have a periodic table review, so it will be understandable. So redox reactions, before heading towards the redox reaction, first we will understand what does oxidation number or oxidation state means. So basically, when we talk about oxidation number or oxidation state, it is the charge present on an element. Okay, it is the charge present on an element. For example, we have a sodium, and if you see there is a no charge on it, so its oxidation number is 0. We have a sodium ion, its charge is +1, so it means its oxidation number is +1. In the same way, here aluminium oxidation number is 0, and here aluminium's oxidation number is +3. Here this oxidation number of sulfur is 0, and here the oxidation number of sulfur is -2. Here the oxidation number of chlorine is 0, and here the oxidation number of chloride is -1. And see, for example, if this is a compound, normally we write NaCl with a no charge. So there is no net charge, but the elements present in it have a positive and negative oxidation numbers. Is this clear?
Yes.
Yes, Khatija, is it clear to you as well?
Yes, sir.
Okay. Okay, then note it down quickly. How are you? Your good name? Your good name? Sayyid? Rohelen. Okay. We have started redox reaction today. Okay. So if you have a notebook, just note it down. I will explain it.
Sir,
Yes.
sir, I have a question related to the metals. That
Okay.
in metals, is transition metals also included?
Is transition metal?
Is also included, like its properties and all that.
No, their actual specific properties are actually included in periodic table.
Okay, so transition metal is in periodic table chapter.
No, the reactions, the general reactions which any metal can do, whether it's a transition or not, we all have covered in the previous chapter. But the properties which are only specific to transition metals and the other metals do not have those properties, that we are going to cover in periodic table.
Okay, and the colors of the metals.
We have discussed the colors. The copper is a pink color solid, and rest of the metals are silver green solid.
Okay.
And about their compounds, we will discuss them in redox and in electrochemistry.
Okay.
Yeah. Are you done, Khatija?
Yes, sir.
Okay. So in redox, first we are going to understand about oxidation number. So oxidation number is the charge that is present on an element. For example, here there is no charge, so its oxidation number is 0. And if there is a ion, so whatever that charge on that ion is, that it will be their oxidation number. Look. Is this clear? Okay. Now in the compound, the net charge is usually zero. For example, if I write sodium chloride, I always write it as NaCl with no charge, right? It is because the oxidation number of these, the sum of the oxidation number of these two becomes equals to zero. That's why it doesn't carry any charge, but the elements in it do have the oxidation number. Is this clear? Okay. Now we are going to discuss the rules how to determine the oxidation number. We have a periodic table with you. Okay, so try to keep it from the next class. Okay. Okay. Now rules. So the first rule says that if there is an element, which means that it is not combined, it is not in the compound, which means it is not bonded to any other element. For example, if I write, let's say, chlorine, so is it element or a compound? If I write
Element.
it's also an element. But if I write HCl, then it's a compound. So if there are
Compound.
elements, yeah, good, Khatija. So the oxidation number of elements is always zero. They are not ions, they are in the form of their atoms, right? Here. So the oxidation number is zero in this case. But if there is an ion, here I have written monoatomic ions. Mono means single. So it means the ion which have a single atom in it. So whatever the charge that ion carry, that charge is actually their oxidation numbers for those ions. Is this clear? Okay. Now, the third point states that if the element is in combined state, which means in a compound like HCl, then now the element have some oxidation number in positive or negative. Okay, if there are two elements, so out of these two, one must have a positive oxidation number and the other must have a negative oxidation number, and the sum of these oxidation numbers is equals to zero, because that compound have no charge on it. Is this clear? Okay, note down these points.
Sir, can you please explain that what is mean by the monoatomic ion?
What does mean by
Monoatomic ion.
mono means single. So there are two kinds of ions. For example, if you did bonding, so you have seen the ion like this as well. There are plus sulfur
Yes.
oxygen, right? And there is a one atom of sulfur and four atom of oxygen. So we call it polyatomic ions. Poly means so many. But if I write
Okay.
O with a two, so how many atoms there?
One.
One means mono. Monoatomic ion is
Okay.
the ion which contains only single atom.
Okay.
Okay.
Sir, done.
Okay. Are you for a demo or you have to the admission? Took the admission. Okay. Okay, now look at these three examples. You guys have written these twice. Okay, so
Yes.
uh, now if we see over here, is there any charge on it? No. Is there any charge on it? Where is the charge? Any charge on it? No, are no charges. So it means we are going to conclude whatever the charge will be, but the sum of these oxidation numbers of these elements must be equals to 0. So put it like this. Okay, put it like this. Now, have a look at periodic table. Magnesium is in which group?
Two.
Group 2. So it means the charge of magnesium is going to be +2. And the net charge is 0, which indicates that to get the net charge 0, oxygen must have a charge of -2. Do it quickly. Sayed Rohil. Rohil. ROHAIL. Which school are you? Defense. Done. Now, in this case, if you look over here, we can't directly put the charge of iron because iron is in transition element. Iron is a transition element. If you see, you are not going to find any group number over there, right? So we take the help from bromide. If you see, bromide is over here, bromine. What is the oxidation number of bromine then?
-1.
7 -1. So I'm going to put a charge of -1 over here, but how many bromine atoms are there? Yes, 2.
Two.
If the charge of bromine is -1 and there are 2 bromines, that makes its charge -2. So in order to get the 0 net charge, the charge of iron must be +2. So +2 and -1 times 2, if you add them, you will get 0. Note it down quickly. Is this clear? Now have a look at third example. Chlorine is in group 7 again. So its oxidation number is going to be -1 and there are 3 chlorine. So it becomes -3 and the net charge is 0, which means aluminium must have +3 oxidation number. Is this clear? Yes, Khatija?
Yes, sir.
Okay. Now, next rule. This is about metals. So when we talk about metals, we have just discussed the rules for the oxidation numbers of just the elements or the ions, right? Now, if the metal is in compound, then remember in compound, the oxidation number of metal is always going to be positive.
0.
No, in element it's 0, but in a compound, the oxidation number of metal is always going to be Positive. If the metal is from group 1, then its oxidation number is +1. If the metal is from group 2, its oxidation number is +2. If the metal is from group 3, its oxidation number is +3. If the metal is from group 4, its oxidation number is either +2 or +4. And if the transition metal, then it varies. It varies from +1 to +7, but it always stays positive. Okay, these all are metals which I have highlighted in the periodic table. This whole region are metals. Okay, now when we talk about zinc, if you see the position of a zinc also have no group, but you have to remember for zinc that its ion is always +2. It doesn't form any other ion, so you have to remember this. In the same way, when we talk about silver usually form +1 ion, so you have to remember this as well for silver and zinc. Okay. Otherwise, when there is a transition metal, the number written in the Roman will tell us the oxidation number, that what oxidation number that atom has. But zinc, it is not written, so you have to memorize this, that the oxidation number of zinc is +2. Is this clear? Yes, Khatija?
Yes, clear.
Okay. Yeah. Are you done? Khatija, are you done?
Yes, sir.
Okay. So you have to remember the positions of metals. If you don't, then just remember that from boron you will make this staircase, and on the left side of this staircase, all are metals. And on the right side, there are non-metals, and which are exactly on it are considered as metalloids. Okay. Now, for non-metals, when non-metals, there is a condition that non-metals are bonded to metals, then their oxidation number is negative. If that non-metal is from group 5, then its oxidation number is -3. If the non-metal is from group 6, its oxidation number is -2, and the non-metal is from group 7, its oxidation number is -1. You guys have noted down these points as well? Yeah. Yeah. Okay. Now, First understand, then copy it, okay? Let me understand. So, the initial 2 points that you have noted down, the last 2 points, one is about metal. When metal is present in the compound, its oxidation number is going to be positive. It's from group 1, it's +1, it's from group 2, +2, group 3, +3, group 4, either +2 or +4, and its transition, it can be any value from +1 to +7, but positive. The second point we have discussed about non-metals, and we have a specific condition that these non-metals must be bonded to a metal. In that case, then oxidation number of those non-metals are negative. If that non-metal is from group 5, then its oxidation number is -3. If the non-metal is from group 6, its oxidation number is -2. And if the non-metal is from group 7, its oxidation number is -1. But those non-metals must be bonded to metal in the last point. Now, here we have a few exceptions or few deviations from that point, and that's what we are going to discuss. You have to understand about hydrogen. Hydrogen have how many electrons in its in the atom of hydrogen? Yes, student. One. So it means hydrogen is going to lose that 1 electron or gain one electron. So the oxidation number of hydrogen is either going to be +1 or -1. So if hydrogen is bonded to any non-metal, when I say non-metal, it means I am talking about these. So for example, if hydrogen is bonded to oxygen, then in this case, hydrogen's oxidation number is +1. If hydrogen is bonded to carbon, then the oxidation number of hydrogen is going to be +1. If hydrogen is bonded to nitrogen, then the oxidation number of hydrogen is going to be +1. Is this point is clear? Now, if hydrogen is bonded to sodium, for example, so sodium is a metal or a non-metal? Metal.
Metal.
The oxidation number of hydrogen becomes minus. Understood? Yes, Khatija, if it's bonded to calcium, then in this case also the oxidation number of hydrogen is going to be minus. So these 2 points cover this thing, that its oxidation number is going to be +1 when it is bonded to any non-metal. Its oxidation number is going to be -1 when it is bonded to a metal. Now, we know we have did that in organic or in ionic bonding as well. Normally, this is oxygen. It's in group 6. So what is the oxidation number of oxygen?
2-.
But when it is bonded to a, what was this rule? When it is bonded to a metal, right? But when any non-metal bonded to a fluorine, then in that case you have to remember this thing. The oxidation number of fluorine is always stays -1, and if fluorine stays -1, then the other non-metal must become positive, because two same charges do not like each other. The attraction is always between opposite charges. So if these two are bonded with each other, then it means if one is a negative, then other must be positive. So that is the rule. Fluorine's oxidation number never changes in its compound. Its oxidation number is always going to be -1. So what is the net charge over here?
0.
0, because we are not observing any charge, so it means net charge is going to be 0. And as we have discussed, the oxidation number of fluorine in its compound is always -1. So it is -1. How many fluorine are here? 2. So it makes it -2. So to make the net charge 0, the oxidation number of oxygen is going to be +2. Is this point is clear? Okay, then the next one. Normally, the oxidation number of oxygen is -2, but with the 2 exceptions. One is with fluorine, that's what we have discussed over here right now. And the other one is with hydrogen, when it forms hydrogen peroxide. So, Now hydrogen is bonded to a non-metal, right? So what will be the oxidation number of hydrogen here?
+1.
+1, right? How many hydrogens are here? 2.
2.
Which makes it +2. So if there is a +2 on hydrogens, then what will be the charge on two oxygens? -2. But there are two oxygens. So what will be the charge on one oxygen? -1. That's how we will get the net charge of -2. So see, there are two exceptions where the oxidation number of oxygen changes from -2 to +2 when with fluorine, and in H2O2 it turns into -1. Is this clear? Okay. I hope you guys have understood. Okay. Now copy it down till the last point that is shown in the screen, and then I am going to discuss the last point as well. Okay, now can you hear me properly, Khatija?
Yes.
Okay. Till then I just offer the prayers. It's done.
Sir,
Yes, Khatija.
sir, I didn't get the seventh and eighth rule.
Okay. So seventh rule says that in a compound, fluorine is always -1. Okay. So whatever the element is bonded to fluorine, if fluorine is always -1, then the other element must become positive. The oxidation number of the other element always becomes positive. Is this clear?
Sir, can you please repeat again?
Yes. When fluorine forms a compound, fluorine always stays -1. Its oxidation number never changes. Okay. In the compound, it stays as a -1. So if fluorine becomes -1, then the other element which must be bonded to fluorine, must have a positive oxidation number, because always opposite oxidation numbers can attract with each other. If they have a same charge, then they are not going to attract each other, right?
Yes.
Now, is this point is clear or not?
Yes, clear.
So if fluorine is -1 over here, and there are two fluorines and the net charge is 0, so that means that here oxidation number of oxygen must be +2. Otherwise, you don't get the 0 charge. Is it
Okay.
clear now?
Yes.
Okay. Here in the 8th point, okay. Normally, what students can do, students have practiced so many times, so students know the oxidation number of oxygen is -2 mostly, right? So what a student do is student put a 0 over here, make it -2 times 2. So it makes the net charge -4. So if it is -4, then hydrogen must be
Plus
+4, right? And there are two hydrogens, so one hydrogen must become +2. Mathematically, if you see, it is correct, but here it is stating that one hydrogen is losing 2 electrons. How is this possible? Because hydrogen have only 1 electron. Understood? Yes, Khatija, did you understand?
yes.
Mathematically, this calculation is correct, but in actual, this is wrong, because hydrogen cannot, it have only 1 electron. So how it is possible for one hydrogen to lose 2 electrons to become +2? So that's why we do it from with hydrogen. Is this clear? Yes, Khatija?
Yes.
Okay. Now, 9th point is written by everyone. Yes, Khatija?
Yes, sir.
Okay, so the 9th point states that the net charge is basically the sum of the oxidation numbers of the elements present over here. So what is the net charge in sulfate ion?
0.
Why? You are not observing any charge over there. Why you are saying 0?
Sorry, -2.
-2. The -2 is written, so that is the net charge. So what I will do it like -2. So we know the oxygen have -2, and how many oxygens we have? 4. So if oxidation number of one oxygen is -2 and there are 4 oxygen, so what will be the net oxidation number of oxygen over here? -8.
-8.
And the net charge is -2. So we get a one mathematical equation, right? So if it's -8 and is on the other hand of is equals to, there is a -2. So what value over there in that blank, due to which when I solve it, I will get -2? What number I
6.
will add over here, which makes the result -2? Yes, Khatija, you were correct.
6.
10 minus 8 will get you positive 2. Yeah, you are right, Khatija. So positive 6. If we add positive 6 and minus 8, we will get minus 2. Is this understandable? Okay, note it down, this thing. And then we have a order for placing the oxidation numbers. Whenever in a compound we are going to place the oxidation numbers, we always follow this rule. We always going to put the net charge first, which is after is equals to, which is going to be either 0 or -1 or +1 or -2 or +2. Then after that, we are going to put a charge, put the oxidation number of the metals from group 1, group 2, and group 3 only. Then we are going to put the charge of hydrogen depending upon the other element. We are going to put it either +1 or a -1. Then we are going to put the charge of fluorine, which is -1 if fluorine is there. And if not, then oxygen. And there are 3 possibilities we have seen. Usually, most of the time, its oxidation number is -2. But depending upon the conditions, as we have seen, it might turn into +2 and -1. And then, if there is any other element, then we put their charges at the end. And when we take the sum of the oxidation numbers of these, then it is going to be equal to net charge. For example, here net charge is -2. So when I add the oxidation number of these two elements, it is going to be equals to -2. Here, the net charge is 0. So if I add the oxidation number of these two, it is going to must be equals to 0. Okay. So do this quickly. Yes, Khatija, did you understand?
Yes.
Rohel? Nahil? Yes. Okay. Then Rohel? Yeah. So we have to follow this order when we are putting the oxidation numbers, okay?
Done, sir.
Okay, Khatija.
Sir,
Yes.
can you please give any example related to the last point?
Any other element?
No, any example for the last point?
Last point of this one, the polyatomic ions?
Yeah, no, any other element that is written in order for the placing oxidation numbers. So the fifth point written in this is, so can you please give an example of it?
Yeah, I'm going to give you these examples. These three, I'm going to solve it for you guys. And then rest of the questions is your homework that you have to figure out the oxidation number of all these before next class. And I'm going to solve it these three for you so you guys can understand. Okay, just note these down and note it twice so you know that what is the actual thing and where you are going to work on the other one. Okay, Khatija?
Okay, sir.
Yeah. Okay, yes, Khatija, have you noted down?
Yes.
Okay, let's start with this one. We have two elements, phosphorus and
Oxygen
oxygen. What we need to do at first? What was
net
the
charge
net charge? So what is the net charge over here? Yes,
3 minus
minus 3. So do it like this as I'm doing. Put the minus 3 charge. Why is it in that place? How you will do the work? You have to keep it after 2 3 months. Okay. Okay. Now have a look over here. You have a group 1, group 2. Is P or O present in? No, it's in the power. See, not like this. PO4 is equals to minus 3 or 2 over the power. Yes. Okay. So is phosphorus P phosphorus is in group 1? No. Is it in group 2?
no,
No.
no,
Okay. Is it in group 3? No. So it means our first
no,
rule is overruled because there is nothing from group 1, group 2, and group 3. Now the second rule says, what is the second rule? No, the preference order, the placing order. What is the second? We have to put hydrogen. There is no hydrogen, right? Then we have to put the oxidation number of fluorine. There is no fluorine
fluorine and then
and then oxygen, right? So I am going to write the charge of oxygen in this such case minus 2 times 3. So see, P comes to the any other element. Did you understand, Khadija? So P is
yes,
get the any other element, the last one. So the net charge is minus 3. Minus 2 times 3 gives me, oh sorry, it's 4, not 3. Minus 2 times 4, minus 8. So what will
minus
we do over here to get the charge of minus 3? We should read
5.
positive 5. So it means this phosphorus have a plus 5. Do it quickly in your notebook. Yes, Mananjal, understandable. Gohel, understandable. Khatija, understandable.
Yes, sir.
Okay. Now look at over here. What is the net charge?
+1.
Less one, right? If you see, you can see nitrogen is already over here. So it means nitrogen doesn't belong to group 1, group 2, and group 3. So we are not going to. Then we have to put the charge of hydrogen. And nitrogen is a metal or a non-metal. So it means the oxidation number of hydrogen is going to be +1 or
-1.
+1, because with a non-metal hydrogen is +1, with a metal hydrogen is -1. So +1, how many?
Yes.
4 makes it +4. So what will be the charge of nitrogen to get the net charge of +1? Minus
-3.
-3. -3 + 4 is equals to +1. Did you understand? Okay, note it down. This, if you guys have any confusion, to ask. Is it clear? Yes, Khadija? Everybody done this example? Okay.
Yes.
Now look over here. The net charge is -2. If
2
you
minus.
CR is over here, so it means no element from group 1, 2, and 3. So we are not going to put their charge. Then hydrogen, no hydrogen, then oxygen. So I'm going to put the charge of oxygen -2 times 7. So if it's -2 times 7, it becomes -14.
-14.
So what will be the charge over here to get the -2? +12. And how many chromium atoms are over here? 2. So that +12 is for both the chromium. So what is the charge on one chromium? 6. +6. Very good. Is this clear? Yes, Khatija?
Yes.
Okay. Now look over here. There are 3 elements now. Okay, first do it. Then, yes, you understood how to do it. Okay. Then, okay. What is the net charge over here? 0. Right?
0.
Right? Okay. So sodium is in. So I'm going to put the charge of sodium
Group 1.
+1. Then we have to put the charge of hydrogen. No hydrogen is there. Then according to the order of placing order, we have to put the charge of fluorine. No fluorine over here. Then oxygen. So the charge of oxygen is -2, and how many oxygen are here? 3, which makes -6. Net charge is 0. It's +1. So what will be over here to make it 0? What number we have to put in middle? 6. There is a +1 as well. So what number I have to put in middle? -5. Are you sure? Isn't it going to be +5? +5 +1 makes it +6. +6 and -6 is 0. So the charge of iodine over here is +5. Okay. Do this, and then these, the rest These are your homework. Take the screenshot or the picture. You have to do it for the next class. Then I will show you. You will copy that down. But first, take the picture or screenshot of all of these. Done? Yeah. Yes, Khatija, are you done? Okay, there is one left and I hope to. My bad. Now take it. Khatija done?
Yes.
Okay. Now, if anyone doesn't complete it, complete this and do the homework before the next class. Okay. If you are done, you can leave. Khatija.
Done, sir. Allah Hafiz, sir.
Allah Hafiz.